This video will focus specifically on the application engineering requirements for 1 and 2 valve feedwater systems. It is strongly recommended that the Power Industry Application Series HRSG Feedwater and Steam Valve Operation Overview video be watched prior to this one, as that video goes into detail on the functional operation of the entire feedwater system. When a boiler feed pump is started, both the Feedwater Startup and Regulator valves will be closed, and the boiler feed pump recirculation valve will be open. As a result, the inlet pressure to the feedwater valves will be very high, while the downstream pressure in the HP drum may be atmospheric. It is important that both the feedwater regulator and startup valves shut off tightly, and Fisher recommends that Class 5 shutoff utilizing 800 pounds per lineal inch of seat load be used. If the valves start to leak, 3 different things happen. First, the valve seats will start to wear due to cavitation damage across the seats, and because of the subsequent erosion, the leakage will increase over time. If the leakage rate becomes high enough during startup, the leakage flow can cause the drum level to increase uncontrollably. This is an undesirable operating scenario, and the only way to maintain the drum level is to blow down the extra water. This is costly as it is a waste of water and heat. If the leakage becomes high enough, it is possible that level can still increase uncontrollably, even though blowdown valves are open. In this case, plant operators may start and stop the boiler feed pumps every few minutes to maintain drum level. This is a very undesirable operating condition. Large pump and motor combinations are generally designed for 1 start and stop per hour. Cycling the pumps on and off more frequently than this can significantly shorten the life of the pump and motor. The feedwater startup valve is sized to handle 20 to 30% of the HRSG maximum flow. During startup, the feed pump discharge pressures will be at the highest output, while the downstream pressure in the drum will be relatively low, ranging from atmospheric pressure to a few hundred psi. The pressure drops across the valve will cause heavy cavitation, therefore anti-cavitation trim must be used. The valve most often used for feedwater startup is a Fisher HPT with Cavitrol 3 3-stage trim installed using an HTS1 option OmniSeal and Class 5 shutoff at 800 pounds per lineal inch of seat load. Cavitrol trim can handle pressure drops up to 3,000 psi using 3 stages of cavitation protection. There are Cav 3 designs that can handle pressure drops greater than 3,000 psi. Please consult with the factory on options for your specific application. While Cavitrol 3 trim is an effective solution to prevent cavitation damage, over time, because of clearance flow, the seat area on the plug can become damaged and will exhibit gear toothing. The valve seat will show similar damage, and leakage through the valve will be excessive. An effective solution to provide extended life, if gear toothing is an issue, is to convert the plug and seat ring in a Cavitrol 3 trim to a protected inside seat design. This design moves the seating surfaces to the inside of the plug and an inner ring on the seat ring, often extending shutoff life 2 to 3 times that of standard seats. One thing to note on protected inside seats is that the unbalanced area increases over the standard trim design and the port area is smaller. A detailed valve and actuator sizing review should be performed before a conversion is considered. In some cases, the inside seat design may not have enough flow capacity for the application. If there is a substantial change in the unbalanced area, it is possible that a larger valve stem, new bonnet, and possibly new actuator will be required, which may make the conversion impractical or uneconomical. There is a perception that feed water is clean. However, it is common for varying amounts of magnetite, rust, weld slack, and other debris to flow through the feedwater system, which can plug up the valve trim. To further extend trim life, conversion to a Fisher DST may be the best solution. DST has the ability to handle particulate up to 3/4 of an inch in diameter. All of the pressure reduction occurs below the seat, so there is little to no pressure drop across the seats and subsequently minimum erosion. Another option for new plants or for an existing plant willing to cut pipe and weld in a completely new valve, the notch flow DST may be an option. Notch flow is very effective in dirty service, high-pressure drop applications. While traditional Fisher anti-cavitation designs are flow-down and highly customizable, the notch flow DST is flow-up and non-customizable, but has a very attractive price point. The Feedwater Regulator valve is used to deliver high flow rates to the HP drum at non-cavitating pressure drops. The typical valve used in this application is a Fisher HPT with equal percentage trim. This valve is typically sized so that when it is 20% open, it matches the CV of the Feedwater Startup valve at 80% open. This split-ranged sizing methodology, known as the 80-20 rule, provides a smooth transition from the small valve to the large valve with minimal plant upsets. Traditionally, a two-valve split-ranged configuration has used the small valve with anti-cavitation trim for startup and then transitions to the larger valve for higher flow requirements. In recent years, changes in operational demand have required plants to start up faster and operate under more severe operating ranges. To better handle these harsh demands, we have recently started changing the configuration of the valves, where the large valve now has dirty service trim installed and the smaller valve uses linear trim. This allows for very fast drum fill rates and high cavitating pressure drops, as well as quicker startups at higher operating differential pressures. The majority of the plant operation occurs on the very robust DST trim, and then the small valve with the standard trim is used as a trim valve for the last 20 to 30% increase in load to full load condition. A very popular retrofit in existing plants using two valves for the feedwater system is to install a single valve that will handle both the startup and normal operating conditions. When a single valve is used, a special characterized cage is required to prevent cavitation damage. The lower travels of the cage use anti-cavitation trim for the startup and low-load conditions. The higher travels of the cage use larger drilled holes or windows to provide the flow rates needed for normal operation. If a single valve is used, the differential pressure between the pump discharge and drum needs to be monitored by the control system. An interlock in the control system should be established to prevent the valve from opening past the anti-cavitation portion of the trim until a non-cavitating differential pressure is reached in the system. This example shows valve stage operation as limited by drum pressure. As drum pressure rises, additional valve stages will allow increased water flow. At the same time as differential pressure across the valve drops, its position can increase as allowed by the drum pressure. This will prevent cavitation throughout the valve operation.